Hollow Penny Lab Part 2. So just a reminder, we took some pennies and then the last time we scuffed those with a file. And if you look really close, I think you'll be able to see kind of a silvery thing. That is the zinc core, which contains most of the mass of this penny. How much of the mass? That's what we're going to find out by doing this reaction. So we got a copper shell, which is almost like paper-like, and then we got the zinc inside. All right, and I think I can take this off right here, but I should grab my safety glasses instead. And now, what happened when I left that overnight? So we put the pennies in, they started bubbling. Don't know if you can see this. The pennies are floating on top. Okay, so probably a little bit of that hydrogen that was produced is kind of trapped inside that shell, keeping it afloat. That might end up bubbling out. I don't know if you want an overview cam, if you can see that better. This might be good. This might not be good. I can't really tell, but that's one look. Another look is right here. And hopefully you can see these pennies are floating at least on the top of the surface. And then I have these little etch marks. I probably put 4 or 5 etch marks in each one, or chances where hydrochloric acid can meet in with the zinc. And I did it not just in one region, I did it all over the penny so that it could essentially clean and react with, or take out all of the zinc in that reaction. So the next part of this lab is I'm just gonna dump a little bit of this solution here because we're gonna test that in a bit. And the rest of it, I'm going to dump it in the sink. You probably can't see that, and I'm okay with it. And what I'm just going to do, so I'm dumping the rest of the solution off in the sink, and I'm just going to flush it with some water a couple times. I thought I had some distilled water here. Here we go. And I'm just going to flush that really good. I'll probably do a couple extra flushes with that to get all that acid out of there. And then what I'm going to do is put this on a paper towel and blot it and dry it. Okay, so I want to do that. So probably do a couple rinses with this, get rid of the water. The pennies are down here. Just make sure we get any leftover acid if there is any. And I'm going to do another rinse. And just dump that out and dump that out. And then I'm going to either let it dry or blot it dry right here. You can see like our shells of our penny are essentially hollow. There's a little bit of water mass on there that I want to dry out. They're kind of a lot more bendable than they were before. I don't want to snap them in half. So I think what I'm going to do is just show one other piece. It looks like all the zinc reacted. Okay, but what I'm going to do is take a piece of, this is pH paper. I'm going to put it in neutral water. And you can see it's kind of just turning orange. I got a little acid tip on my finger, that's why it's red. If I put a pH paper in, like this strong acid, this was the solution we started at, it definitely turns red. What if I put it in the container that I drained at the end? Was there any excess hydrochloric acid at the end? Pretty conclusive, pretty red. This was the acid before, this is the acid after. So, you know, even though some of the acid went away, there was definitely an excess of acid there. And that's why we had enough to chew up all the zinc. That was the point, was to have an excess of acid so we could use up all of the zinc. And that verifies that right there. Okay, next thing is I'm going to go to a screen share and bring this up in some data that we have for part 2. So I am weighing these, and when I weigh those, I determined that the mass of the penny after the reaction was just 0.07 grams. So the copper shell weighs 0.07 grams. The penny before the reaction weighed 2.50 grams. So you can subtract to figure out the mass of the zinc. And then you should be able to figure out a percent composition of copper in the penny. Remember, the mass divided by the total times 100, and the same, or the mass of the copper over the total times 100, and then do the same thing with the zinc. So you should be able to figure out those percent compositions.
and a lot bigger composition of zinc in these pennies. Zinc is a lot cheaper than the copper, so that seems to make sense. Then there's some calculations. You're asked, I think we talked about writing a balanced equation for this. You can look at your common ion chart. If needed to, hydrochloric acid is HCl. These other ones you can pick up from common ion chart. Remember, hydrogen is part of Brinkelhoff's. By itself, it travels in pairs. Balance it, and then you're asked a series of questions. So here's one about what type of reaction it is. You have a single thing and a double thing, what looks like is taking place and what's replacing what. I'll let you figure that out. How many moles of zinc reacted? Well, you know the mass of zinc reacted. So you can either use a box like this to answer question 3, 4, 5, or you can use a mole train, which is, I think I just put it on the next page and say, oh, I know the mass, I can figure out the moles, I can figure out the moles of hydrogen and the mass of hydrogen. So whatever you want to do to solve that, I kind of have that here. This mass is what you're getting from the front of the data table. And then you're using that mass to do all these other theoretical calculations. Okay, when you get to number 6, it's asking for a volume. 1 mole is 22.4 liters. So if you figure out moles, you just have to go outside the box and convert to liters there. And questions 7 is, we've talked about this in this video, it's not a calculation, it's a thinking problem. Did all the zinc react? Okay, what happened at the end when I put the pH paper in? And this last one is a percent yield question. It gives you a couple hints about things. And again, if you look at question number 6, you have your theoretical yield, and then this is the experimental yield, and you can do a comparison to see what that would be. Okay, the last page, I think I talked about this in the last video, it's not the same conditions, okay, that we have here. So, you don't know what the limiting reactant is. If I had 32.7 grams of the zinc and 0.80 moles of hydrochloric acid, you would want to figure out the limiting reactant. Use an ice box, you know the moles of this, convert this grams to moles, figure out what that is, and then use the ice box and answer the corresponding questions that we have right here. All right, we'll be not only will we do this in class, especially the second day, we'll probably look at these calculations and have you work with them in class. Thanks for watching. Let me know if you have questions.